Alright, we're gonna look at the problem of proving in this setup ABCD is square, right? And P is a point inside the square such that PAB angle equal 15 degrees, and it's also PBA is also 15 degrees. And we would like to prove that the triangle PDC is regular. In other words, all sides equal to each other, right? All sides are congruent. Now, it turns out that we can use the fact about 15 degrees. Now, in my previous video, I showed that tangent 15 degree is equal to 2 minus square root of 3. All right, so we're going to use that as a fact in this proof. So most geometry problems would require you to have additional lines, right, to assist in the reasoning. So here we're going to have a parallel line here. From the point P, we have a parallel line EF that is parallel to AD and BC. All right, so EF, passes, passes P, and EF is parallel to AD, and this was parallel to BC. Now, this is a square, so we know that PE is actually perpendicular to AD. Now here, we have to use the property of isosceles triangle, right? So because we are given that the PAB is congruent to PBA is equal 15 degrees. So this tells us that this is triangle PAB is isosceles triangle, right? So because let me see. And the corresponding sides equal to each other. So PA would equal to PB, right? Not only that, but also the attitude here would be PE, and the attitude PE is going to be the bisector of the base. What is the base? Base here is AB. Alright? So, in other words, E is a midpoint. Of AB, right? So, since, the EF is parallel in this square, so we would know that this F is also the midpoint here, right? So from here, we know that F is midpoint. Of DC. Now, since this is perpendicular, right, and so PF is the bisector, so PF is perpendicular and bisector, right? So this tells us that PD would equal to PC. All right. So any point, okay. So if you have any segment, anything on the perpendicular bisector. So if this is perpendicular bisector here, all right. Now any point here would be equidistant, right? So this one would equidistant, and any other points, would form a. Okay, so this is a property of perpendicular perpendicular bisector. Okay, so any point here, if at P, they would equal to each other, right? So this is just a side note, right? So we're going to put this as a side note here, right? Okay, so sorry, let me move it here. All right, now, so we have proven that this PDC is isosceles, right? So PD would equal to PC. Now, in order to prove is regular, so it is enough to show that this angle is 60 degrees, right? So this angle equal this angle. If we can show that it's 60 degrees, then we're done. Now, how do we show it's 60 degrees? All right, so let's use the fact that tangent 15 is equal to this. All right, this is 15 degrees. So let's figure out what is the PE, the length of PE, divided by the length of BE. That would equal tangent of 15 degrees, right? And that would equal to 2 minus square root of 3. All right. So now we're gonna try to find out the value. We call this alpha, right? So we want to show the alpha is 60 degrees. How do we show that? Let's figure out tangent alpha. Tangent alpha equal, by definition, is PF divided by FC. Okay, and FC of course is equal to BE, right? So FC is equal to PF. FC is here, right? FC is here, right? And BE is over there, so equal to each other, right? So BE. And what is PF? PF is actually equal. This is PF, right? Equal the whole thing with EF minus PE. So PF, let's rewrite the PF, which is EF minus PE, all right, divided by BE. Now you may ask, what is the relationship EF? What's EF? The EF is full length here, right? The full length here, EF, is actually equal to BC, right? So here we can replace this. This is actually equal to BC, but BC equal to AB because it's a square. AB equal to twice of BE. Alright, so this BE is a midpoint, right? The BE here is a midpoint. So if you plug in here, this becomes, we replace this to 2BE minus PE and divided by BE. Okay, this is a fraction. Alright, so this fraction, we're going to see that there's two parts of it, right? So the first part is actually, they cancel. It actually becomes 2 minus, the second part is going to be PE minus BE. What is PE minus BE? What is this part here? So what is this part? It happens to equal tangent 15 degree, right? So, and we know tangent 50 degrees is equal to 2 minus the square root of 3. So this is equal to 2 minus the square root of 3. And that will, use some algebra, this would equal square root of 3. So tangent alpha equals square root of 3. So alpha equal 60 degrees. Alright? Now, since we know this PDC is isosceles earlier, but now this angle equals 60 degree, so this would be 60 degree, and the remaining would also be 60 degree. So we have proven that the PTC is a regular triangle. Alright, so that's the proof. Alright, so we find that the key here is the knowledge that tan 15 degree equal to 2 minus square root of 3. Alright, so that's it for today.